Have you ever wondered how companies like Netflix can instantly spin up thousands of servers during peak streaming hours, or how Amazon Web Services can host millions of websites simultaneously on their infrastructure? The answer lies in one of computing's most transformative technologies, virtualization. At its core, virtualization is an art of abstraction, creating virtual versions of physical resources from servers and storage to networks and operating systems. In 2023, when ChatGPT experienced unprecedented demand, OpenAI leveraged Microsoft Azure's virtualization capabilities to scale from handling thousands to millions of requests per second. This wasn't just a simple matter of adding more servers. It required sophisticated hypervisor technology like Microsoft's Hyper-V to create, manage, and orchestrate thousands of virtual machines, VMs, in real time. The hypervisor, acting as a traffic controller for compute resources, ensures that each VM receives its fair share of CPU cycles, memory, and I/O operations. But what makes modern hypervisors truly remarkable? Their ability to perform CPU instruction set virtualization through technologies like Intel VT-x and AMD-V, enabling near-native performance for virtualized workloads. Share your thoughts on how virtualization has impacted your organization's scalability in the comments below. The real magic happens when we get into containerization, the lightweight cousin of traditional VM-based virtualization. Docker and Kubernetes have revolutionized how we think about application deployment. Instead of virtualizing entire operating systems, containers share the host OS kernel while maintaining isolation through Linux namespaces and C groups. This approach has enabled companies like Spotify to deploy microservices at an unprecedented scale. They manage over 200 million active users through a complex orchestration of thousands of containers. What's truly fascinating is how containers can start up in milliseconds compared to the minutes required for traditional VMs. Can you even imagine the implications of this speed difference for real-time applications? Network virtualization adds another layer of complexity and possibility. Software-defined networking (SDN) and network function virtualization (NFV) have transformed how data centers operate. Take Cloudflare's global network, for instance, where they use virtualized network functions to provide DDoS protection, load balancing, and SSL termination across 275 plus cities worldwide. Through virtual network overlays created using protocols like VXLAN and Geneve, they can isolate customer traffic while maintaining the flexibility to move workloads across their infrastructure transparently. Comment below if you have implemented SDN in your network and share your experiences. Storage virtualization has evolved from simple RAID arrays to sophisticated software-defined storage solutions. Companies like Pure Storage are pushing the boundaries with their flash array products, which abstract the underlying physical SSDs into virtual storage pools. These pools can be dynamically allocated, providing features like instant snapshots, deduplication, and compression, all without the application being aware of the underlying complexity. The future of virtualization is heading towards even greater abstraction. With serverless computing and edge computing, AWS Lambda, for example, takes virtualization to its logical extreme. Developers simply upload their code, and AWS handles all the underlying virtualization magic. This has enabled companies like Coca-Cola to process millions of vending machine transactions worldwide without managing any servers. Meanwhile, edge computing platforms like Fastly's Compute at Edge use innovative isolation technologies like WebAssembly to run customer code closer to end users. Will we eventually reach a point where the distinction between physical and virtual resources become meaningless? Share your predictions for the future of virtualization in the comments below. Please like and subscribe for more content like this. Also, comment down below if you have insights to share.